Let us find the nth derivative of this function y is equal to x by x plus 1 into x plus 2. So to find the nth derivative of this function, we'll use the method of partial fraction in order to find out the nth derivative of this type of function. So we can start it in this way. Given y is equal to x by x plus 1 into x plus 2. Now, this one x by x plus 1 into x plus 2 can be written as, by method of partial fraction, we can write as a times divided. There are two factors in the denominator, so I can write as a upon x plus 1, the first one, plus b into x plus 2. So we have to evaluate this value of a and b from this one in order to find the nth derivative of this function separately, and then after that we can combine it. Now, multiplying on both sides, by x plus 1, that is the denominator of this term on the left hand side, we have on the right hand side now it will become what? It will remain as x, because x plus 1 and x plus 2 will be cancelled with this one. So you have to multiply in the numerator. So this will become x, and then if you multiply x plus 1 into x plus 2 to this side, then you'll see that here x plus 1 will be cancelled. So you'll have now a into x plus 2 plus b into, now when you multiply x plus 1 into x plus 2, so x plus 2 and this x plus 2 will be cancelled, so you get b times of x plus 1. Name this as equation 1. So now, next step, what we need to do, we have to evaluate these constants a and b. So to evaluate this constant a first, what we need to do, let us substitute x is equal to minus 1. When we put x is equal to minus 1 here, then this term will be 0. So therefore, you get the value of a. So now you put x is equal to minus 1 in equation 1. We have on the left hand side, it will become minus 1 is equal to a into minus 1 plus 2 plus b times of minus 1 plus 1. So this will become 0, and so you'll get this one, minus 1 is equal to a only. So which means that the value of a is equal to minus 1. So we have got the value of a. Now next, you put x is equal to minus 2 in equation 1. Then in that case, what we have now, it will be minus 2 on this side. It will be equal to a into minus 2 plus 2 plus b into minus 2 plus 1. So this will be cancelled, so it will become 0. So you'll get here minus 2 is equal to minus 2 plus 1 here, it will become minus 1. So you'll get it as minus b. Minus and minus can be cancelled. It gives you the value of b as 2. Therefore, let us substitute the value of a and b. A is equal to minus 1 and b is equal to 2 in this given equation. So let me name this one as equation star. So putting the value of a and b in star, values of a is equal to minus 1, b is equal to 2 in equation star, we have x by x plus 1 into x plus 2. This is equal to a, it will become minus 1 by x plus, what is that equation star? Let me go back again. It is x plus 1 plus b, that is 2 by x plus 2. Or I can simplify, I can write it as 2 by x plus 2 minus 1 by x plus 1. But what is this term on the right hand side? X upon x plus 1 into x plus 2 is y. So this implies that the value of y can be written in this. So in this way, and then name it as double star. So separately now we can find out what will be the derivative of this function and also the derivative of this function in order to find out the nth derivative, that is yn. So here what we have to denote now, first you take, let u is equal to, I'll take 1 by x plus 2, because the here if I take it as 1 upon x plus 2, so I can find out the nth derivative of this term, because this 2 will not have any effect on that one. So when you, after getting the nth derivative of u here, then you can substitute it here, so it will be 2 times of whatever be un. So now let us find out what is u1. This can be written as x plus 2 to the power minus 1. So then u1, that is the first derivative, it will be minus 1 into x plus 2 to the power minus 1, which is equal to minus 1 into x plus 2 to the power minus 2. So you have got u1 to be that one. Now next, what is u2? u2, you differentiate this u1 one more time, then you get minus 1 will be there. So it will be minus 1, then into minus 2 into x plus 2 to the power. Now it will be minus 2 minus 1, which is equal to minus 1. Now how many minus are there? Minus into minus, so you'll get as minus 1 the whole square. Then 1 into 2 you can write, then x plus 2 to the power minus 3. So this implies that u2 can be written as minus 1 to the whole square. Now 1 into 2 can be written as 2 factorial. 2 factorial, then into x plus 2 to the power minus 3. Now next, let us find one more derivative of this one, that is u3. Now what is u3? You differentiate this u2 one more times, then that constant term will remain as it is, minus 1 to the whole square, then into 2 factorial will remain as it is. So if you differentiate x plus 2 to the power minus 3, so minus 3 will come out, minus 3 into then x plus 2 to the power minus 3 minus 1, so it will become minus 4. Here using the derivative of d dx of x to the power n is equal to nx to the power n minus 1, where x here is what? It is x plus 2. Okay, so by using this formula, you'll get this derivative of this u. So this implies that u3 is equal to minus 1 to the whole square. Another minus is there, so it will be equal to minus 1 to the power 3, then 2 factorial into 3. 2 factorial is 1 into 2, and then into 3 it will become 3 factorial. Then x plus 2 to the power minus 4, or u3 can be written as minus 1 whole raised to 3, then 3 factorial divided by x plus 2. Since the power of this is minus, so in this case you can bring it to the denominator so that the power will become plus. So what we notice is that, what is u1? u1 is minus 1 into x plus 2 to the power minus 2. And in u2 we have this one, it is minus 1 the whole square. See, the order of this derivative, that is 2 here, and the power of minus 1 is same, that is 2. And then 2 factorial, 2 here factorial is same as the order of this derivative. Then x plus 2 to the power minus 3. Now 3 is 1 more than the order of this derivative, so we have it in u2 as minus 1 the whole square, 2 factorial x plus 2 to the power minus 3. Now next, what we found that in u3, again the power of minus 1 is 3, which is same as the order of this derivative, and 3 factorial, 3 here, which is same as the order of this derivative, and the power of x here is 4, which is 1 more than the order of this derivative. And in u2 also we see that it is 1 more. So in general, this will imply that if you continue to differentiate this one, so finally you get un is equal to minus 1. The power of this should be same as the order of this derivative, then into n factorial divided by x plus 2 to the power n plus 1. So finally we have got the nth derivative of u. So now name this as equation 2. Now next, let us find what will be the nth derivative of this one, 1 upon x plus 1. You'll get a similar nth derivative. Instead of x plus 2, it will be x plus 1. Now take v is equal to 1 by x plus 1. Then what is v1? Then v1, this can be written as x plus 1 to the power minus 1. So again, you can use this formula. ddx of x to the power n is n x to the power n minus 1, but instead of x, it is x plus 1. So what will be v1? So minus 1 will come out. Then into x plus 1 to the power minus 1 minus 1, which is equal to minus 1 into x plus 1 to the power minus 2. The power of this is 1. Okay. Now next v2. Differentiate this v1, then you get minus 1 will remain there, then minus 2 will come out, then into x plus 1 to the power minus 2 minus 1, which is equal to minus 1. Now, how many minus are there? There are 1, 2. So it will be minus 1 to the power 2, then 1 into 2, x plus 1 to the power minus 3. Or you'll get v2 is equal to minus 1 the whole square, then 2 factorial into x plus 1 whole raised to minus 3, where the power of x plus 1 here is minus 3, and this 3 here is 1 more than the order of this derivative, which is 2 here. So I'll find one more derivative of this one, that is v3. So v3 will give you what? You differentiate this v2, then you get minus 1 whole square will be there, 2 factorial will remain there, and then minus 3 will come out from here. Then x plus 1 to the power minus 3 minus 1. So this one gives you minus 1 to the power. We have here 2 and then one more minus, so it will become 3. Now 2 factorial into 3. 2 factorial into 3, it will become 3 factorial. So you'll have here 3 factorial into x plus 1 to the power minus 4. So finally, what is v3? It is minus 1 to the power 3, 3 factorial. And if you bring this x plus 1 to the denominator, then you'll get x plus 1 to the power 4. And 4 can be written as 3 plus 1. So what we notice now is that if you continue to differentiate this one, then you'll get Vn will be equal to minus 1 to the power 3 power n. Because if you compare this one, 3 with this power of this minus 1 is same, and the factorial also 3 factorial here, which is the same as the order of this derivative. And in V2 also the same thing, the order of minus 1 is 2, which is same as the order of the derivative, and 2 factorial is same as this 2 here is same as the order of this 2. But the power of x plus 1 is 1 more than the order of this derivative. So here you see that you get it as n factorial divided by x plus 1 to the power n plus 1. So name this as equation 3. So finally we have got the nth derivative of un and vn. That is, we know what is the nth derivative of 1 by x plus 2 and what is the nth derivative of 1 by x plus 1. So therefore, what the nth derivative of y here will be given by yn. Therefore, the nth derivative of y will be yn is equal to 2 times of un minus vn. But what is un from equation 2? It is minus 1 to the power n into n factorial by x plus, let us see what is un from equation 2. From equation 2, it is minus 1 to the power n factorial by x plus 2 to the power n plus 1. So you replace that un by that one, so you'll get it as x plus 2 to the power n plus 1, then minus vn. What is vn? It is minus 1 to the power n into n factorial by x plus 1 to the power n plus 1. So you see that how I find the nth derivative of the function y is equal to x by x plus 1 into x plus 2. So the first step is that apply the method of partial fraction so that you can easily find out the nth derivative. Like in this case, x upon x plus 1 into x plus 2 can be written as a into a upon x plus 1, which is the factor of this one, plus b times of this term, x plus 2. And then substitute over, cross multiply this one to this side, and you see that finally you'll get the expression of x as a into x plus 2 plus b into x plus 1. So you can find out the value of a and b from this equation 1. So to find out the value of a, you put x is equal to minus 1 so that this part will vanish, and then you get the expression of the value of a. And then next, find out the value of b by putting x is equal to minus 2 so that this term will vanish. And then you, after getting the value of a and b, you substitute it in equation star. And then next, what you need to do, you can find out the nth derivative of this separately. That means you can find out the derivative of 1 upon x plus 2 separately, the derivative of 1 by x plus 1 separately, and then finally yn will be 2 times of, like in this case, it is 2 times of un minus vn. Hope it is clear now how to find the nth derivative of this type of functions, x by x plus 1 into x plus 2 by method of partial fraction.